Hey everybody, so I'm going to explain how we're calculating the amount of fluids the patient needs and at which rate are we um, are we giving this fluid at. So uh, let's consider this case: a 5-year-old child weighing 20 kilograms, 7% dehydration percentage. Calculate the total amount of normal saline to be infused. In what rate should the IV go? So, how are we going to calculate the physio? First of all, we're going like the total amount of the normal saline. So, how many fluids should we give the patient? First of all, we should calculate the physiological need. So there's this rule in the first 10 kilograms. So we're calculating each kilogram at kilogram needs 100 milliliters of fluid. The second 10, it's going to be 50 per kg. And the third 10, it's going to be 20 milliliters. So in this child, it's like 20 kgs. So we're like 210. So the first 10 is 1,000 plus the second 10 has a kilo with 15 milliliters. So it's going to be 1,500 milliliters per day. This is the physiological need. The patient needs this amount of fluid in normal conditions every day. But there's like we don't keep on adding. There is the rule where it says the males their maximum physiological need reaches 2,500 milliliters, like 2.5 liters, while women girls reach 2 milliliters. Um, also it depending on how much the person also uses and what conditions the person is right at the moment if they're on some drugs. So, but the general rule is this. So we've got the physiological need. So now we're gonna calculate the deficit. So if they said 7% dehydration, basically the deficit amount is going to be weight in kilograms times dehydration percentage times 10. So it's going to be 20 times 7 times 10. It's 1,400 milliliters. In general, we're dividing dehydration into three types, three stages. It's going to be mild, moderate, and severe. Severe is going to be shock. So the mild, we're counting it at as less than 5% of dehydration. The moderate is going to be like 5 till 7, whereas the severe, the shock, it's going to be more than 10% of dehydration. And each one has its own like physical examination findings. The some things that we're classifying each as. For example, we're considering the turgor, the tachycardia, the capillary fill time, the overall look of the patient. Okay, so we've got the deficit amount. So now we're gonna just add. It's gonna be 2,900. So we rounded up to 3,000 because we're not gonna calculate in a 100 milliliters or less, so it's going to be all decimals. So let's do three liters. So in general, where the rule says 50% of the amount needs to be infused in 1/3 of the time. So we're gonna go with 1,500, it's like half, and to 24 hours, like third of that is like 8 hours. So um here we're gonna calculate the rate. So it's like 1,000 divide 8, the first 1,500. It's gonna be 187. It's like roughly 200 milliliters per hour. It's gonna go at this rate. So in our hospital, the IV fluids, where we tend to use IV saline, so it comes in 500 milliliters, 250, 100 bags. So the maximum is like 500. So that amount, milliliter bag, so we're gonna divide that by the rate. So 500 divided 200, it's that's how we calculate the time for each bag. So if we have like two 500 bags, so it's gonna be in 6 hours. The second 500, we're opting for 5% glucose. uh, it's gonna go at a rate of 3 hours. So basically, if we're saying 1,500 of fluids, the patient should get in 8 hours. So let's say like it's gonna be in 9 hours. It's fine. We're gonna round it so that each 500 it'll be 3 hours. And we can do this glucose. We can mix what I don't mean like actually put one inside of the other, but we can use normal saline and then glucose. We can do two at a ratio of 2:1, to saline, and one is the glucose. Let's consider this second case. Here we've got the 5-year-old weighing again 20 kgs. The hydration percentage is 7%, and the glucose is, they measured their glucose amount is 2.5 milliliters per liter. So, what are your next steps? How do you manage this patient? Over here, this amount of glucose is, so this patient is hypoglycemic at the moment. Uh, so the typical range of the normal glucose should be 3.9 till 5.5 milliliters per liter. So what do we start? Do we start with glucose or fluids? We start with glucose. We um, correct the hypoglycemia first. So we're gonna use other rate measurement. Sorry, 2.5 to 3 milliliters per kilogram, and this should go in 3 milliliters per minute. We're gonna use 10% glucose over here. So 2.5 to 3, you can opt for 2.5. So it's gonna be 50 ml. 50 divided 3, it's like 6.6. So roughly in 15 minutes, this 10% glucose should go. 50 milliliters of 10% glucose. And then we're doing the exact same thing as calculating the total amount of the fluids physiological need of the patient. 20 kilograms, so 1,500 milliliters, plus the deficit amount of 7%. So weight times 7 times 10, 1 times 400, roughly 1,500. So total amount of fluids the patient should get is 3,000. One half of that is going to be 1,500. So we're going to do 1 liters in 6 hours, and then 500 ml of 5% glucose in 3 hours. I hope it was clear, guys. It's something like in the beginning you don't understand what's going on, but it'll, after you reread it and then practice it in real life, it tends to get easier. But I mean, going over it again and again really helps, especially after seeing cases. Sometimes they just attending doctors know by practice this child's gonna go like 500 ml in 4 hours. They don't really calculate all these steps. They just out of practice they know that this amount of fluid is like 4 hours is good. But I do suggest getting a hold of this formula, and just to be in a safe track. Thank you guys so much for watching. I hope you guys all stay safe. Bye bye.